Okay, but why?
Hi everyone, and welcome to today's episode of Okay, But Why, where my face seems bright and clear for a change, thanks to all of these lights that I've installed in the room. But even so, you can't see all of my face, can you? Yeah, just as I thought. I mean, come on, you can't see the millions of individual cells that make up my skin, or the tiny protein molecules that make up the hair of my eyelashes, or even the tiny water molecules that cluster together to form droplets of sweat in the pore of my skin. I'll stop right there. But essentially, what I'm trying to say is, it may seem like white light is nature's blessing to help us see everything around us. But there are things that are so tiny, in fact, that even the brightest, whitest light in the world cannot help you see them. But why not? And how do you see these invisible things? Well, to answer that question, we need to understand what seeing means in the first place. For instance, if I want to see those two objects A and B on the red board, then all I would need is a few light rays to bounce off of them and meet at my eyes. Now this seems simple enough, doesn't it? But what happens when the objects get tinier and tinier? Well, I can't shrink these objects anymore or you won't be able to see them. But what does happen when I shrink those objects is that these light rays appear huge in comparison to them. So all I need to do to simulate tiny objects is show bigger light rays. So let's have some bigger light rays on the screen. There we go, nice fat light rays. And of course, when they bounce off, they meet not too far from the object itself. So you're going to have to get closer to the object to see it. That makes sense. If I want to see a tiny fly at the end of the room, I would go closer to it. And the tinier the object, the closer I would go. And if I wanted to see atoms, then I would need to be at a distance of literally a trillion times smaller than even a meter. That's not realistically possible, is it? So there you have it, ladies and gentlemen. That's why no matter how powerful your microscope, if you're using light, you're not going to be able to see atoms and molecules at all. In fact, as one famous scientist said, using visible light to see atoms and molecules is just like using a cannonball to shoot a mosquito. So anyway, now that we know the problem, what is the solution? Well, all we need is a type of radiation with thinner light rays that can conveniently converge at a realistic distance. So as you can see, ladies and gentlemen, smaller arrowheads can make a huge difference in life. Just like that one tiny arrowhead on the screen that you can move with your mouse to click on the subscribe button and help support my channel. Now, the scientific word to describe the size of radiation is known as its wavelength. And that's why you will always observe scientists explaining that to view tinier objects, you need radiation of lower wavelengths. And that, ladies and gentlemen, is the fundamental principle of the field of structural biology. Now, if you want to know what some low wavelength radiation seem like, then they are X-rays, or gamma rays, or neutron beams, or electron beams, and so on and so forth. But I'm sure you would notice that all of these types of radiation that I mentioned are extremely powerful. Of course, you wouldn't want to be anywhere near them without your safety equipment. And also, it's because they're powerful that it's going to be extremely difficult to focus them to form an image using lenses or microscopes or cameras. And so we have a whole bunch of complications to deal with before we can use them to see stuff. Oh, and you thought today's explanation of seeing things was complicated? Well then, ladies and gentlemen, I must say that I'm afraid you haven't seen anything yet. Until next time, I'm Varun from Okay But Why. Stay safe, stay curious, and stay tuned for the next video.